I hope you had a nice break. Well, my presentation is going to be about the emissions and sinks of greenhouse gases on farms. And the goal is to try to define what we talk about when we talk about carbon neutral agriculture and really give an overview of these emissions and sinks in order to take effective steps towards carbon neutral agriculture. So let's start by what is carbon neutral agriculture. So farming systems have the ability to reduce their emissions and to increase removals of greenhouse gases. And we already saw how this is really important when we have ambitious goals that were mentioned this morning, like reaching carbon neutrality in 2050. So as shown in this figure, emissions from farming systems occur in the form of different greenhouse gases, namely methane, nitrous oxide, carbon dioxide. And once in the atmosphere, these contribute differently to the greenhouse gas effect, as was also already pointed out by one participant this morning. So this is truly important. For instance, we know that nitrous oxide and methane have warming potentials, which are many times larger than that of the same amount of CO2. So in order to account for the actual greenhouse gas effect, all the emissions are accounted in terms of their CO2 equivalents. So if we add the emissions and the removals, we get the net emissions. And of course, if these two terms are equal, we can reach a carbon neutral system. And this is in terms of its CO2 equivalence, which refer to the warming potential of the system. So therefore, this balance can also be referred to as climate neutrality. So this is just to clarify that this is what we want to be talking about here today. So to reach this balance is not definitely always an easy job, but that's why we are here today. So we can move to the next question, and that is in the next slide. And here we really also need to be aware of what is included when we talk about carbon neutral agriculture. So when we look at the farm level or at a farm product, we have to account for all the emissions and removals that are related to that farm. And this is what is called the life cycle perspective. And in the farming systems, we can identify these three blocks of sources as shown in the figure. So first, on the left, we can see that there are the emissions that arise from all the inputs that are used on the farm. But they were made somewhere else, such as the fertilizers, the feedstuff that is bought, and all the materials and energy. And then we have the emissions that actually occur during the production on the farm. And these are mainly the emissions from enteric fermentation, if there are ruminants, from manure management, if there is any livestock, from soils. And here, this is referring to the emissions that are resulting from nitrogen application to soils. We have also the emissions from the use of energy and fuel, and the emissions and removals from land use and land use changes. And then finally, if the products are processed on the farm, for instance, in the case of a state bottled wine, the emissions from this processing and packaging in the form of materials, machinery, and different forms of energy, they are also included. So after looking at these main sources and sinks of emissions, we can move to the next slide. And this is showing us how we can start to design a strategy to reach carbon neutrality. And here we can identify three main steps towards this goal. Well, we can avoid emissions, we can decrease the emissions, and then we have to increase the removals. So how can we avoid emissions? Well, a farm can have some renewable energy production, can decrease losses, and it can implement circular economy measures, recovering energy, nutrients, and materials. Well, it can also decrease its emissions. And here we are referring to innovation measures aimed at decreasing emissions from enteric fermentation, for better processing of manure, for less nitrogen emissions from soils. But this also means efficiency measures to decrease the use of energy and all inputs on the farm. And then also to reduce the emissions, the carbon emissions from soils, for instance, by applying minimum mobilization practices or cover crops. But still, finally, we have to increase, or we might have to increase the removals. And this can occur through soil and the vegetation. So by a sustained increase in the soil organic matter, or by an increase in the perennial vegetation, for instance, in edges, in less productive areas, but also by introducing it into agricultural areas where they can benefit the ecosystem. This is the so-called agroforestry. So finally, my idea was to show you how this can look like at the farm level. And to do this, I took two examples, one from an annual crop farm and another from a dairy farm. And these examples are adapted from case studies from a live project called Agri-Climate Change. And they were actually published by DG Internal Policies, so you can look them up there. And these case studies, they are examples of real farms and of implemented measures. So they can actually be taken up by other EU farms. So this is the first example, and it considers an annual crop farm. It's a farm with about 180 hectares in France, which has a rotation of cereals, protein, and oil crops. So you can see here in this figure, it has the baseline of the emissions from this farm. And we can see that the largest fraction of emission is coming from the nitrogen applied to soils, followed by the emissions from the fertilizers themselves, and emissions from fuel from the operations made on farm. We can also see that the removals is this small fraction that is negative. It's quite slow. It's just about quite low. It's quite about 5% of the emissions. And now we can look at the mitigation measures that were taken up by this farm in order to walk towards carbon neutrality. And these were an optimized fertilization plan, the introduction of nitrogen fixating crops and cover crops. And these two measures contribute to decrease the use of fertilizers and to decrease the emissions from the nitrogen applied to soils. And direct seeding was also implemented over the entire area after a timely process. And this also contributed to reduce the fuel consumption. So overall, the emissions here were decreased by about 45%. But at the same time, the direct seeding and the cover crops contributed to increase the carbon removals by the agricultural soil. And also the farm implemented some measures to increase removals by the vegetation through edges and a small area of agroforestry. So overall, the removals were increased, and we can see here that they offset over 60% of the new level of emissions of this farm. So now we can take a look at an example from a different kind of farm. And this is a dairy farm. This example is from also a conventional farm with about 50 cows located in Germany and with some area for permanent grassland. and a small area where silage is produced. So on the right, we can see again the emissions from this farm in the baseline. And the main ones here arise from manure management, you can see, followed by emissions from soils and emissions from fertilizers, and only in fourth place, the enteric fermentation in this case. So here, the mitigation measures that we are gonna analyze is the implementation of a biogas plant. So this plant degrades the manure into methane, which is used for electricity production on farm. And this decreases the emissions from manure and also from the electricity. And then the solid fraction of the digestion is used as fertilizer. And this reduces the emissions from soils and also from fertilizers. So overall, this single measure contributed to a decrease of about 52% in the emissions. And this could be, of course, complemented with measures towards the removals in order to come closer to carbon neutrality. So this was it that I could present to you today in my very short time. I thank you for your attention, and there will be room for questions and answers regarding these concepts and the following presentations after the next speakers. So
thank you,